Hello and welcome. Today we will be discussing how to solve systems of linear equations using elimination. So as I mentioned in a previous video, there are three methods for solving systems of linear equations: substitution, elimination, and graphing. So today we will be focusing on elimination. In our equation over here to the left, we have a system already set up, two linear equations that we need to solve for both the x and y value that makes the situation true for both equations. So using elimination is slightly different than substitution. When we worked with substitution, we were isolating a single equation. We were working on an equation one at a time, isolating a variable. In this situation, what we're going to be doing is working concurrently with both equations to isolate a variable and solving from there. What we want to do first here is isolate either our x or y variable. So in order to do that, what we have to first understand is we're working on these terms vertically now. We are saying 3x plus 2x, 2y plus 5y, negative 6 plus 7. But what I want to do is eliminate one of my variable terms, either x or y. So how can I possibly do that? Well, if you notice, I have a 3x here and a 2x here. Both of these terms happen to go into something. They both go into 6, relatively easy. If I multiply this top term, for example, by a positive 2, that would make this a positive 6. But what I would like to do is get rid of that term. So what I can do is multiply this equation down here by a negative 3. Because by doing so, it's going to turn this into a negative 6x, and it'll allow me to eliminate them. I'll show you how that works. So we're going to distribute this value 2 times 3x, 2 times 2y, and 2 times negative 6. Remember, multiply that value by every term. We're trying to maintain that balance of the equation. We cannot just multiply one of the terms by 2. So it's going to be 6x plus 4y equals negative 12. Our bottom equation here is going to change to negative 6x minus 15y equals negative 21. And now what I want to do is I want to start solving. And what you've noticed here is my x values. They are the inverse of each other. The inverse allows me to eliminate them from the equation. Just like in substitution, we wanted to use inverse properties to move things. We're using inverse properties to eliminate variables here so that I can start isolating variables and solving for them. So if I work on this vertically, 6x minus 6x is going to be 0, so those cancel out. 4y minus 15y takes me to a negative 11y, and negative 21 minus 12, or negative 12 minus 21, takes me to a negative 33. I have one last step here. The inverse property of multiplying negative 11 times y is dividing by negative 11. This will allow me to isolate my y value, and what I do to one side I do to the other, and I get my value or my solution for y, which is negative 33 divided by negative 11, which is a positive 3. So I now know y is equal to 3. But just like in substitution, we are not finished, right? We've solved for one variable, we need to go back and we're going to plug it in, just like we did with substitution. So I can plug it back into either of my equations here. I'm going to choose my top one. I'm going to say 3x plus 2 times 3, because this is 2 times y, so that's 2 times 3, and this is equal to negative 6. I'm going to start simplifying here. 3x plus 2 times 3 is 6 equals negative 6. Inverse property of addition is subtraction. This will allow me to remove my positive 6 from this side, start isolating my variable of x. Because remember, we want to get x by itself at this point. We're trying to move everything else out of its way over to the other side. Negative 6 minus 6 gives me a negative 12. Divide by 3 on both sides, and we get our solution for x. X is equal to negative 12 over 3, which is also negative 4 simplified. So now I have my solution set. The solution to these two, or to the system of equations, would be negative 4, 3. And that is how we solve a system of linear equations using elimination.